So now we're going to move on to EIGRP authentication. And I broke EIGRP authentication out of the main lab just simply because you're not actually configuring EIGRP. You don't go into the router EIGRP AS number command to configure authentication. Authentication is an interface level command, but we'll get into that here in just a bit. Now, to enhance security, you can configure MD5 authentication for EIGRP updates. Now, why would you want to do that? Well, quite simply, it's a security function. If security is not configured, an attacker can set up a router, learn your network topology through all the routing updates that get sent between all the routers. So then they have knowledge about how your network is laid out. They can kind of draw inferences based on the metrics that EIGRP gives them. Or they could go more aggressive and inject bogus routes into the network, take down your WAN, cripple communications, or just simply route all the traffic through that router, which they then use to sniff every bit of traffic crossing your network. Now, when you configure MD5 security on the interface, it uses the security for not only the neighbor association, but also for any routing updates that get sent. And because this is an interface level configuration, each interface can use a different security parameter if you so desire. For example, you might have one MD5 keyring that points out towards your WAN connections. You might have a different, more complex MD5 key that points towards your internal core network routing updates. Now, if you'll recall from our overview of EIGRP, security parameters are one of the things that's compared when the neighbor association is formed. And quite simply, if the keys don't match, then the neighbor relationship is not valid. It's not formed, and you can't exchange routes with your neighbor. We'll see this in the lab. As soon as I configure authentication on one of the interfaces, you'll see that the neighbor association goes away because the neighbor doesn't have the key yet. So security requires an MD5 keyring, which is configured in the router configuration. The keyring can have one key or multiple keys. If it has one key, then it uses that same key for all communications, and that one key never expires, or it should never expire, or else your communication will break at some point in the future. So it's best practice to not specify an end date and time if you have only a single key. Now, because the MD5 implementation on Cisco routers looks through the keyring in the order that the keys were presented and uses the first valid key that it finds, if you have multiple keys with expiration dates and times, you should define the keys in the same order in all the routers. That way you know this specific key will be found when the proper date and time parameters are met. And of course, it goes without saying that router clocks should be synchronized on all the routers that use authentication, else there might be a few minute variation in the clocks on the individual routers, and you might end up with a period of time where one router thinks the key is not valid any longer, but its neighbor router, because it's a few minutes slow, thinks the key is still valid. Therefore you have mismatched MD5 authentication and your neighbor relationship will fail. And that's EIGRP authentication in a nutshell. We'll go through the lab and set up authentication on some of our core links, and you'll get to see how well this works or doesn't work, depending on how badly we manage to break it. But that concludes our overview of EIGRP authentication.